What if you could watch an atom formation not from equations, not from approximations, but from raw subatomic particles, just like in the early universe? Say if subatomic particles are distributed around the simulation box and you can see the atom formation. No predefined orbitals, no quantum shortcuts, just the raw dance of electrons, protons, and neutrons self organizing into matter. In this study, we used Monte Carlo and molecular dynamics algorithms to do exactly that. Using the code written in Fortran, yep, the old school, we simulated a hydrogen atom, carbon atom, and even a uranium atom. What you're seeing here is atom formation of a carbon atom, where the protons, electrons, neutrons are distributed around the box, and it self-assembly itself into an atom. What makes this groundbreaking isn't just the visuals, just the simulation videos, it's the underlying physics in it. We developed pseudo potentials for subatomic particles, a new force field that mimic the way real particles attract and repel at different distances. These potentials let atoms form naturally. Protons, neutrons cluster into the nucleus, whereas the electrons orbit without crashing in or flying away from the nucleus. So the new pseudo potentials for electron and proton is like that, where it attracts when it is at the larger distance and it repels when it is at the shorter distance. So they come closer and they repel and they go away, and then again they come closer and they mimic that. What you are seeing here is a carbon atom simulation using a molecular dynamics algorithm where the nucleus is protons and neutrons present in the center as a cluster and the electrons revolving around the nucleus. As you can see, the motion of protons and neutrons affects the motion of electrons revolving around the nucleus. Now the atom is stable and we have Monte Carlo molecular dynamics simulations. Now we can implement pilot wave theory on this motion of electrons around the nucleus, where the motion of electrons is guided by the three-dimensional medium waves of interference pattern between the nucleus and the electrons. As you can see in the figure, the black one is a nucleus, black circle is a nucleus, and the two red circles are the electrons revolving around the nucleus, where it possesses three-dimensional medium waves and is and its motion is affected because of the interference pattern between the three-dimensional medium waves. So the advantages and the massive implications are it's a new way to simulate atom and molecules from the inside out, and that's a bridge between the classical and quantum models, and it's also a tool for attosecond physics, atomic structure, and even quantum computing. Here is the uranium atom simulation, where you can see at the center it's a nucleus where all the electrons are revolving around the nucleus using molecular dynamics algorithm. Here I want to see this approach for a bigger atoms like uranium atom, and the atom was found to be the stable, and you can see here the atom is a stable with having electrons revolving around the nucleus. Thank you for watching this video, and please like, share, and subscribe to your friends, those who are interested, and please check the description box for the full paper where you can find the simulation of oxygen molecule where two oxygen atoms are placed side by side and the electrons are getting shared between the two nucleuses. Thank you for watching.